See where it came from? Okay, now is where finish the sentence, Joe. Now is where we can take advantage of this chemistry to allow the isomerization. If this group, which deprotonated here, now can reprotonate this oxygen, if it can reprotonate this, right? So if something deprotonates this falls down, this pair of electrons can go over here. This becomes the ketone, this becomes the carbanion, right? They sort of skip that step. So something deprotonates the 2-hydroxyl. It tries to become a ketone, but in doing that gives this carbon now 5 bonds. So this pair of electrons can come here and be a carbanion stabilized by this new carbonyl. And that can then be protonated.
So is that a carbanion next to a negative oxygen?
Yeah, so, right, again, right, note the magic. Yeah, somewhere this oxygen got protonated in the process. They're being vague about the source of that hydrogen ion. But I would guess your concern is exactly correct. That we're not going to create a carbanion next to this negatively charged oxygen. So before that can happen, probably what has to happen here? It's going to get protonated. They're just being vague about the source of that protonation. Right? So this comes down, you create a new carbanion. Now you have your carbonyl on carbon 2 instead of on carbon 1. You've taken advantage of carbanion chemistry in this enediolate that lets you do it on a... We started out with the carbanion on this carbon. We ended up with the carbanion on this carbon because we had 2 oxygens that could act as the carbonyl. Now the enzyme catalyzes the ring closing step. That is, this has to act as a nucleophile. Some base has to deprotonate it. That opens up. And again, what happens when it opens up? We get a magical protonation, right? And then a magical protonation occurs, and we're done. That product can be released, a new substrate can be bound, and we can go through the cycle again. And each step is fully reversible. So again, if fructose 6-phosphate is being produced, it is bound, we go through the process backwards. Okay? If fructose 6-phosphate is being produced, or back to my morning, right? If you're drinking a drink made with a lot of high fructose corn syrup, and that fructose is being phosphorylated, eventually resulting in the formation of fructose 6-phosphate, you make a lot of fructose 6-phosphate, it goes backwards to glucose. Or it goes on through glycolysis and becomes this thing right here, but that's a different story. Right? We'll get there. So that's an important mechanism. We will continue glycolysis. I'm not going to, don't let me go through this mechanism again when we get to those other enzymes, because the mechanism is essentially identical.